So in this video, I'll be talking about an application of decision curve analysis for online fraud detection. So there's a lot of ad fraud out there. So online advertising can be a major issue for digital ad networks. So there can be click fraud, and that's a common type of ad fraud that's used to scam ad networks. So there are a lot of sites out there that can be dishonest as well, and they're trying to scam digital advertising networks for some financial gain, which is not nice. But there are all sorts of people and things in this world, unfortunately. So there's like bot-driven ad fraud as well. There can be click bots producing fake clicks on digital ads that appear on properties that scammers own, generating revenue for them. So we want to figure out and we can use machine learning to judge user behavior against a baseline, identify users that are likely to be bots. So you can filter out malicious bot activity while real users and good bots are allowed to continue interacting with a web property like normal. So in this case, we want to see if we can come up with machine learning models to predict honest websites from fake websites. If you're trying to advertise, I'm trying to figure out who's a scammer, who's not a scammer. So this is sort of like just some extension that I wanted to create just to show how decision curve analysis could be used there for advertising networks. So I'd sort of worked in advertising sales in the past as well. So we were looking into precision advertising or addressable, where you can target specific individuals based on demographics, interests, age, and whatnot. And yeah, there are indeed a lot of different things that fake scamming bots can do to confuse poor companies, advertising companies. They can come up with click farms, so large groups of people who get paid to click on ads. So you think that people are actually interested in buying your product, but no, they're not. These are actually people who are paid to just click on it, pretend that you got the impressions, the eye views for your product, but you actually didn't get those. So that's very misleading. There's also ad injection, so you can add ads into a website without the editor's permission. You can also place more ads in the same ad placement with ad stacking as well. So you're putting more ads than what the advertiser wanted. Or you can place an ad into a single pixel, so you're trying to get away without advertising what you promised the advertiser. So you are a dishonest ad site, you're very dishonest. You're inserting ads into a website without their permission. You are cookie stuffing, so you're attaching cookies to users without their knowledge, trying to get personal information. You could do domain spoofing, where you present low profile websites as premium ones. So this is sort of like what we're going to look into, like domain spoofing. Like, what is the ad actually a premium site? Is it actually a very good website, an honest website? So is it premium, which is honest? Or is it low profile, which is dishonest? And this is honest. So that's sort of like the issue, and we're going to kind of focus on that issue. So let's pretend that we have these predictive models that can utilize some metrics to figure out if a website is dishonest. And if it is dishonest, then you don't advertise on that. And you can figure out which sites are honest, which are non-scammers and which ones are scanners, spammers, I mean. And I want to show you guys another example of decision curve analysis, which is for online fraud detection. So, online advertising clicks, imagine, 130 sites. You have ad model A, ad model B, ad model C, and ad model D. So this is just another example
And the positive case is that the ad site is an honest site. So you have 130 different sites. Are they honest sites or are they not? So there are 4 different prediction models for determining if a website is dishonest or honest. And then your positive case is that you have an honest ad site. And the negative case is that you do not have an honest site.
So basically, in online advertising fraud detection, you sort of want to determine, if it is a website actually a dishonest website or is it not a website. So you have these 4 advertising models, models A, B, C, D, and how do you choose which one? And you're trying to predict the probability for the 2 outcomes. There's an outcome like 1 and then 0, and 1 is saying it's honest. It's an honest site, and you can definitely like change it around, and it won't make any difference. Like you can make honest 0 and 1 being bad, and then this one is a bad site, is 0. So those are the 2 groups here. So it can be either honest or it can be a bad site. So those are the 2 groups, and you have the models and max net benefit for the treated. So this is just basically the actual ad sites out there that are honest, which is like about 43.1% of the ad sites out there. So treat all is probability that whatever is a true click. That's what treat all is saying. That let's just assume that every site out there is a great website. So that's just like almost like a very naive, very sweet thought, very rosy thought. Let's just pretend every site out there is a good site. That's what treat all is. So it's like Sandy's treat all approach. Let's just pretend every single site out there is just lovely. It's just honest. It's not bad. And treat none is like Peter's very cynical view. Let's just pretend like every website out there is bad. Let's not go to any of those sites for online advertising clicks. So that's a treat none approach. And this is a treat all. And you have your 4 predictive models in between that can help you try to determine, based on some metrics that each is respectively using, is that website really an honest site or not? What's the probability that it's an honest site? So you could look at this net benefit on the treated, the sites that are actually honest that you've ended up detecting as being honest. You could look at net benefit on the untreated, or you could look at net benefit overall. Either interpretation, any of the 3 is the same. So let's just focus on the sites that are actually honest that we could detect. And you can see here it's like very, very complicated. Like green is dominating, then it seems like maybe yellow is doing slightly better, and then the brown, and then it's like, jaggedy, and that's sometimes why, it gets a little bit hard to quantify a model that way. It can be a little bit hard. But nonetheless, I tried to just figure out just some general thresholds to help you guys. By and large here, it seems in this region, you'd want to treat all. So you want to pretend like that every one is honest. So if you really have a 12.5% threshold, 0 to that, if at 12.5%, then you believe, or anything below, you're going to say that a site is really reliable, even if there's like a 5% chance that it is an honest site. If you still, if it just needs a 5% chance of being honest for you to honestly say that, or honestly think that it's an honest site, then you might as well just think everything's an honest site at that rate. That's what it's trying to say. If this threshold is 5%, that means that I'm going to predict a website is honest if it has a predicted probability of being honest that is 5% or above. So really, even if there's just a 5% chance it's honest, I'm going to predict it's honest, it's positive, then I might as well just predict everything is positive. Like, why not just blanket, like, don't even need a predictive model, don't even need to spend that kind of time on it, just, or run any models. Predictive models take time as well to make predictions for websites, so just
treat everything as being honest and just be a little bit naive and go with it. That's what this is saying, if that's your threshold. But if you really start to get stricter, like, let's say the site needs 13% or above for you to think it's honest, then maybe at this point, as you have a higher threshold for it to be honest before you say it's honest, then like at those points you might need to start using these advertising models like C, D, A, C, D. And you'll notice that like we use C, we use D, and we use A, but we're not using B anywhere. So maybe that's just a model that we should just not use. So that's like another thing that you can uncover using decision curve analysis. You can potentially detect that one model is just not really that good, and that at some points it's just not worth it to have a predictive model. If your threshold is so low, you might as well just go with Sandy's view and like just think everything is honest. If you have such a low threshold, like if there's a 10% chance of it being honest and you're still going to think it's honest, honestly, you should just think every site is honest. There's a 90% chance it's not honest, but you're still wanting to go with it being honest. That really means you really deep down, you're an optimist and you like to see the best in every site, and you like to see the best in every site. That's like a word pun. Anyways, you just like to see the best in everything, and that's just saying that you should just think every site is honest, not use any predictive model, and go believe that result. Go with my approach and treat all. If this is your threshold, if it's 10% chance of being honest and you still think that site is honest, if it has at least a 10% chance of being honest, you're going to assign it to the positive class. It's a positive site, it's a good site, then you should just predict every site is honest. Don't even spend the time with these predictive models. So you also could see that it doesn't make any sense. So you won't see the treat none here in the zoomed in, because honestly all of them it would be like at 0. It's always 0 for the net benefit on the treated. So that is like the blue line is always like here. I can't even draw a straight line. It's always at 0. But none of these like are dipping below, so I just had zoomed in over here. So what you're going to notice is that it's better to either use a predictive model here or just to assume all sites are honest than to assume Peter's view that all sites are negative, they're dishonest. That does not really work for us here. But Peter's view is actually only beneficial if your probability threshold is 82% to 100%. That is, if you need a site to be honest, it needs to have at least an 82% predicted probability of being honest. If you're going to be that scared and that cynical, you might as well not even use any of these ad sites or believe in them. So here you're very pessimistic, you're a downer. And here you are incredibly optimistic. So here I am very pessimistic. I need the ad site to have at least an 82% probability threshold for you to treat. If that's your threshold, is if it's 82% or anything higher. If you need your ad to have 82% probability that is predicted of being honest for you to think it's honest, that's a pretty high probability, pretty hard to get to. So you might as well just treat none. Just assume that all of these websites are bad. Don't trust them. On the other hand, if you're so happy, even if it has 11% chance of being honest and you think it's honest, then you might as well just take every single website of being honest. So these are the two middle grounds here. Treat all, think all are honest. Or treat none, think none are honest. Think all websites are, ad sites here are bad. So you can treat all and think that all of the websites and ad sites are honest and good sites, or you can treat none and think that none are. And in between 0.12 and 0.81, you're going to see that the ad models, based on what I was showing you guys, they tend to vacillate here. At 0.12, it's ad model C. Then when you switch it around, it's ad model D for these three percent thresholds. 2% is ad model A. Then ad model C really dominates again for 14 percent, from 20% to 34%. And then ad model D does really well again. It is like for 26% of them, it's like pretty dominant. And D again is pretty dominant. So it seems like it's really catering to a wide variety. So it really depends. So either you can count up the number of thresholds for which it's optimal, find the one that's optimal for the most thresholds. That's one way to do it. The other one is to see which one is optimal for the threshold of your choice. The other advantage that it does is it allows us to eliminate ad model B. So a middle ground can be successfully achieved between Peter's and Sandy's views, so between, based on your risk preferences. So imagine your company like Procter and Gamble, for instance, and you're trying to determine, ad websites as well. So based on your risk preferences, like probability threshold, the ideal predictive model to use will differ. So between 12% and 81%, if you have a threshold probability between this wide range of 69 possible thresholds, a prediction model, one of our 4 ad models, can be very beneficial. But ad model B is not useful at all, and it can be discarded. And that's an advantage that we also get from decision curve analysis. We can also shrink down and just say, okay, now we're left with these 3 ad models. And it can be really cool because you can then maybe make it hybrid and say, hey, you enter in your threshold, different advertising managers can enter in their threshold and risk preferences, and then maybe it can be something where, like, if your threshold is any of, if it's 12%, I'm going to give you ad models, or if it's 20 to 34% or 62 to 78%, I'm going to give you ad model C. I automatically take you to that ad model. But if it's between 13 and 16%, or 35 and 61%, or 79 and 81%, I'm going to just automatically route you to ad model D. Otherwise, if it's between 17 and 19%, I'm going to route you to ad model A. Based on this, I might just even altogether just eliminate ad model A unless you really are hung up on 18% as a threshold or 17%. It's just not really that optimal for many thresholds. So that's another thing. We can probably just get away with model B and model A and just simplify it a bit, and then just compare D and C at this threshold and see which one is higher and use that one. So Procter & Gamble will use the suggested model that corresponds to the probability threshold to generate predictions for those ad sites, and will advertise only on those ad sites with predicted probability that the site is honest, that is greater than or equal to the probability threshold. They're going to use the suggested model or the approaches, and then they're just going to advertise only on those ad sites that meet the criteria for their threshold. So that's just an example of how you can use different models. You can use your thresholds, and then you can generate predictions and work with those. And just the point of this again is decision curve analysis is widely used, especially for medical decision making. But I wanted to show you that you can just be creative. Honestly, all you just need is you need a set of predicted probabilities and 2 classes, like a positive class and a negative class. And you need a model that is just giving you predicted probabilities of being positive. And then you can just run the code and run the model and generate the results. And you can just kind of interpret it this way for even an advertising, for instance, not just healthcare. So I really tried to push beyond and come up with an example that could also show you how you can use it in diverse disciplines. Of course, this may not be life and death, pun intended, like in healthcare, but it can still be pretty useful having a threshold probability, because especially like in the finance world or advertising world, you do have people's money at stake as well, and those can be pretty life-changing in some way decisions, not like life and death per se, but people's money are tied up, and you might want to make the best decisions. Otherwise, your company could sink. So you could have a lot riding on the success, and you might want to use this for business decisions or for evaluating different models, machine learning models, for making predictive decisions, but different outcomes. Like, do you think it's a good stock, not a good stock? What's this, so on. So it's different applications, and it just needs you to be creative. At the end of the day, it's all in your hands to come up with the different predictive models and come up with the best one to use. So you can use an ensemble, which is just like a network and different approaches of predictive models. It all depends on you guys
and your creativity. So yeah, please let me know if you have any questions on this at all. And I'm Sanya, and I'm just so happy to help. And if you found this helpful, please subscribe to my YouTube channel as well. Thank you, guys.